I know something about you. You love modularity. We all love modularity. We spend all day breaking our code down into modular functions, grouping those modular functions into classes, into packages, architecting modular microservices, organizing our front end into modular JS and CSS, organizing our data into modular tables and schemas and databases. But why do we love modularity so much? Modularity gives us isolation, right? We can make changes in one part of the code base and not have to worry about breaking something completely unrelated somewhere else. We can isolate parts of the system with greater performance concerns, higher security needs, and yeah. But modularity also gives us comprehension, the ability to understand complex systems. Imagine if you had to hold an entire system in your head, all at the same time. Think about the code base you're working on now, right? Imagine if you wanted to make a change to that code base, you had to have every line of code in your working memory all at the same time. It's impossible. I think psychologists found this out about 50 years ago, and studies have shown that the human brain, working memory, not the brain, can hold about 7 plus or minus 2 chunks. So modularity is super important for comprehensibility too. But modularity also gives us the ability to have autonomy. And I think this is neglected. Modularity enables us to work in parallel on individual parts of the system without constantly tripping over each other and getting in each other's way. Super important. A few years ago, I was working in the UK government, and we had a nice modular architecture like this. I was working with some teams in the digital space, and the organization had existing teams in the enterprise IT space. In digital, we were doing something new, part of a massive digital transformation right across the UK government. So in digital, we're doing continuous discovery, continuous delivery. We're talking to customers every single week, getting feedback and improving our services. And then during one iteration, we started to get feedback, very negative feedback, and users were telling us, I can't register with your service. Your address field is 3 lines long. My address is 5 lines long. I can't even use your service. I still have to use paper. Now, that's kind of a big deal when you're building a service for businesses that enables them to pay business property taxes, and they need a business address to register with the service. And we're like, hey, continuous delivery, continuous discovery, we're developers, we'll fix it. We'll make that 3-line address field 5 lines long. And then a week later, I'm sitting in a meeting with 5 project managers to put a text box on a web page. Kind of frustrating. 3 weeks later, I'm sitting in a meeting with 5 project managers to put that text box on that web page, trying to get all of these teams to work together just to get that text box extended, updating the data APIs, the business rules, the database, the internal systems. It's crazy. And this is happening on every piece of work. And I'm getting super frustrated with this, and so are the people I'm working with. And so I start talking to the heads, the management, heads of IT. I'm like, look, our system needs to have better modularity so teams have more autonomy. Every piece of work is taking so long and causing so much pain, we have to fix it. No one listened. No one cared. Yeah, Nick, whatever. So I'm getting super frustrated, and I'm thinking about quitting. And then I get this email, and it says, there's going to be a meeting next week about those architectural things you've been talking about. So now things change. So I'm super excited about this meeting. I can't wait for this meeting. I'm hoping they've listened to what I've said. I gave them amazing architectural diagrams, value stream maps. I was convinced they'd listen to me. So it gets to this meeting the next Friday. It's a beautiful sunny day. People are wearing shorts and eating ice cream. It doesn't happen a lot in the UK. I've got this super positive feeling that something good's going to come out of this meeting. I get to the meeting, and the head of IT, He's sat at the end of the table. He's got his elbows on the table. He looks like he means business. And he does mean business because he says this: programmers have been too slow. So we've bought a generic rules engine, so we don't need the programmers. Not what I expected when I woke up that day. That's not what I was expecting. And I tried to tell him, I'm like, but I think there's another approach here. And I fumbled, and he's like, no, ask him. Who was he pointing at? He was pointing at the consultant selling the generic rules engine. I wanted to cry, and I did cry. And I've got a question for you. How many project managers to put a text box on a web page now? We've made the problem worse. Now, these problems upset me. It's frustrating when you can't do simple changes in a big organization when it should be easy. But do you know what frustrates me more? When I see things like this, and I see it a lot, when I just see developers moaning, oh, it's a management problem, I wish management would fix it. Developers go away and moan and stuff. I don't agree with this. And I want to explain why this is wrong. So think about our goal. We're here to evolve a software architecture. Our goal is to have a software architecture we can evolve faster than our competitors. If our architecture is more evolved and we have features our competitors don't, we'll have a competitive business advantage and hopefully we'll get more customers. But in order to do that, we have to have the organization set up in the optimal way to evolve the architecture. So if you want to evolve the architecture, you have to shape the organization as well. It absolutely is your responsibility. So whenever you think of software architecture, it's not really a thing, in my opinion. You can't really architect a software system without understanding the teams that will build it. It's socio-technical architecture, and you are socio-technical architects. So let's just take a quick minute. I've been told it's impersonal to do talks without bio. So my name's Nick. I've written a few books. I'm a consultant with Empathy Software, and we're a member of the Equal Experts Network, a bunch of independent consultants who work on high-profile projects. If you're interested in becoming an independent consultant in the network, get in contact with Equal Experts. I'm not just towing the company line here, but I'm working on, at the moment, with a client in New York on like a revolutionary IoT system. It's super interesting. So Equal Experts may have some interesting opportunities for you as well. Back to today's talk. So how do you go from thinking about technology mostly to thinking like socio-technical architects? What are the changes you have to make? Is it complicated? I don't think so. But one thing I've learned is that when I look at people who make good architectural decisions, those people have an amazing commercial and political awareness. Like some of the people I look up to in our industry, some of the smartest people I've worked with, I always thought they were like technical geniuses. But no, they understand the business and they understand the organization. That's how they make great choices. Now, just want to clarify something. I'm not talking about this kind of office politics, right? I'm not saying you've got to put your colleagues' stapler in jelly, laugh at your boss's jokes, make up rumors about your colleagues so you get promoted and they don't. I'm not talking about office politics, not that kind of crazy stuff. So let me give you an example. So you've been hired by one of the biggest tech companies in the world. You've moved to the big city, and you can't wait. You can't wait for this opportunity. But as soon as you get there, you notice some problems. Every piece of work is taking so much time to implement. People aren't happy. The system's got bugs. You're like, oh no, this is supposed to be my perfect job and everything's messed up. But that's okay. I'm going to fix it. So you form a group, a working group with some of your new colleagues, and you're like, right, I've noticed the architecture is the problem here, and the way the teams are set up is the problem here. We're going to fix it. So you start investigating some alternative architectures. And the first one you look at is an activity-oriented architecture. Now, this style of architecture is where we have horizontal layers of specialists. Front-end teams own the front-end code, back-end teams own the back-end code, DBAs own the data. Each layer is full of people 100% doing what they're best at, focused on their core primary skills. But then you decide to look at a different kind of architecture. You're like, what if we go for a partner-aligned architecture? So the company you're working for is a big, massive tech company. You're working in the marketing business unit. You build marketing products, and one of the products you're working on is a big advertising toolkit. Enables businesses to run advertising campaigns on Twitter and Facebook and LinkedIn. And in your working group, you're like, hey, why don't we have services and teams that own them aligned with our partners? One team will own everything about Facebook. One team will own everything about LinkedIn, etc. So you're kind of excited by this. But then you're like, let's try one more. So then you look at a capability-aligned architecture. What if we have full vertical slices? So, for example, a creatives capability. So when you see an advert online, a creative is the images, the text, the video, the noise. That's the creative. What if you have like a creatives capability? One team owns everything about creatives. Facebook creatives, Twitter creatives, LinkedIn creatives. So then you get to the hard part, like which one are we going to choose? And if I had to choose one of those cakes, I'd have to choose all three. But you're going to have to choose only one of these architectures. So who's going for activity-oriented architecture? Ready? Finished? Who's going for partner-aligned architecture? Who's going for capability-aligned architecture? Right. Seems to be capability over here and partner over here. Was there some kind of agreement before this talk? Anyway, the correct answer is quite clearly, oh, hang on a minute. I'm just getting a phone call from a head of sales. She wants to add Snapchat support so she can close a massive deal worth millions. Wow. That's interesting. So what kind of architecture would we want now to support this? To enable this kind of change to be easy in our system? What if we want different networks in the future? So, activity-oriented architecture, well, front-end teams do the front-end bit, back-end teams do the back-end bit, DBAs do the DBA bit. We need all of these teams working together to implement this feature. Maybe we can do better. Partner-aligned architecture. And that's interesting. We can just have a new Snapchat service, new Snapchat team. No one else has to get involved or be distracted. Sounds good to me. If we think about capability-aligned architecture, we still need all of those teams to work together to implement that feature. The creatives team do the Snapchat creatives, bidding and budgeting do the Snapchat bidding and budgeting. So we still need all of those teams to work together. So let's take a second vote. Who's going for activity-oriented architecture now? Who's going for partner-aligned architecture now? Who's going for capability-aligned architecture now? I'd love to know what everyone else is going for. But anyway, quite clearly, the correct answer is, oh, hang on a minute. It's the head of product. He's heard about Snapchat, and he's laughing at me. Snapchat, Facebook is 95% of our revenue. We need to optimize our system to be aligned for Facebook. So now how does that affect the architectural choice we go for? Well, if we go for activity-oriented architecture, still the same kind of trade-offs, front-end, back-end, you get the idea. With partner-aligned architecture, we would now be creating a bottleneck on Facebook, one Facebook code base, and only a few people who can work in it. And we'd be pulling away people from Facebook to work on Snapchat. If we look at capability-aligned architecture, we can have each of those vertical slices working in parallel on Facebook. So lots of trade-offs here. So let's have one final vote. Who's going for activity-oriented architecture? Who's going for partner-aligned architecture? Who's going for capability-aligned architecture? Right. So, right, finally this time, the correct answer is, oh, wait a second. There's going to be a meeting next Friday. We've all been invited to a big meeting about the company's architecture. It's the head of IT. He's sitting at the end of the table. He stands up. He's bought a generic rules engine, so it doesn't matter which architecture we go for. Let's not do that. So hopefully you've seen some of the kind of trade-offs. We've seen economical trade-offs, the way we slice our architecture. Those architectural slices represent independent streams of work in the organization. If we couple things, for example, if we couple Facebook into one stream, the business can invest in that stream without having to invest in related things. We also saw politics. We've got a sales director who wants to have one feature and set of priorities to close a sale and get her bonus, but we've got a director of product who's focused on the long-term strategy. So lots of different factors. How do we start thinking about all of these factors ourselves when we're making architectural choices? So I think the answer is patterns. I know a lot of people don't like patterns, but patterns are super useful. We can take what we understand from one situation, understand the trade-offs, and when we're in another situation and we notice the same pattern, we can spot those problems early. When we're designing systems, we have a choice of architectural styles and patterns that we can use to make the best choices up front. But I know patterns don't work everywhere, and I'm not saying patterns work everywhere. But what I'm promising you is, when you start looking for patterns, you start developing the mindset of analyzing situations, looking for the economical, political, and technical trade-offs. And those skills will help you in any situation. Those analytical skills will help you in any situation. So we've already seen some kinds of patterns. We've seen activity-oriented, partner-aligned, capability-aligned. There are many patterns and styles. So I'm going to show you a few of the patterns that I've been seeing over the past few years. First one is the dog food context. So everyone's familiar with the term dog fooding, right? Dog fooding is when a company uses the products and services they've built. Now, a dog food context is really interesting because it's not about maximizing revenue and optimizing flow. In fact, a dog food context is where a business becomes a client of their own products in order to gain the experience their customers get. You don't want to create an amazing dog food context. You want to feel the pains your customers are feeling. So let me give you an example. Some years ago, I was working for like a music streaming company. They built this amazing platform where any company could build their own streaming and downloading service on top of it. Like the APIs enabled you to search for music, stream it, download it, etc. Now, in these yellow boxes, we've got clients who are using the APIs. In the blue box, we've got a team inside the company who are acting as an external client. They were building like a white label service to get the same feedback customers were getting so they could improve the core product. So what are the economical trade-offs when we see this pattern in play? So it's not about making loads of money. This isn't where the business wants to invest huge amounts of time for a massive payback. We may even make a loss on the dog food context. It may make no money at all. Getting that feedback is the goal, to improve the company's main products. But it can grow into a product, and this did happen at the company I worked for. The dog food context grew into a product. What are some of the kind of political trade-offs we need to understand with this pattern? Well, firstly, everyone wants to work on something important. I want to work on important features. I want to build the features that customers love, make the company money. You see them online, people know about the products. It's not always that attractive to work on a dog food context that doesn't really make much money or have any importance to the company. As a consequence, we start seeing things like deceptive motivational techniques, where managers tell people your work is more important than it really is. And then we have conflicts in the organization where people think their work is more important and they try and prioritize it over other work. So we have to be careful of these things. But the dog food context does have some redeeming technical qualities. If you're working on a dog food context, you should insist that you build it in technologies you haven't used before. Your clients are using different technologies to you, So your dog food context should use different technologies. This is a great opportunity to try out some new technologies and put them in tech, put them in production, get them on your CV. Next pattern is the octopus context. Do all of these patterns have stupid names? Yes, they do. So this pattern is about, we have one context, one team who own a service, and this service reaches out and touches lots of other services and pulls information back. So let me give you an example. Has everyone heard of GDPR by now? I said this like 6 months ago, and like no one had heard of GDPR, and now everyone's heard of GDPR. I bet you've got an inbox full of like 50 emails about GDPR. Anyway, we were building this GDPR service, and it would receive notifications from the customer. Delete all the data you've got about me. Obviously, it didn't because it wasn't up and running at that time, but this is how it was being built. So GDPR service gets a notification, delete everything you know about me from all your systems. GDPR context is like, okay, reaches out to all the services in the company, delete any data you have about this customer, and tell me when you've done it, because I'm going to keep a record in the audit log. And if you don't tell me, I'm going to come for you after 3 days, and you won't like it. So that's the kind of octopus. Have a big fan out of dependencies. Now, what are the economics of this kind of pattern? So the economics are, we've got this dependency from one to many. And if that one has to change its interface or its contract or the way it integrates with all of those teams, it's going to slow down all of those teams. It's going to reduce their flow because they'll have to comply with your new interface or standard. For compliance scenarios like GDPR, it's quite difficult to say what's the cost benefit of doing this change, because it's protecting the company, it's not helping to make more money. So again, prioritizing that work can be very difficult if you're working in that team. Then we get to the politics, and this is really interesting, because if you're working in one of those tentacle teams, and you've got this octopus telling you, imagine you had an octopus telling you, that would be funny. You've got this octopus telling you, I'm making some changes, you need to update your system by next Friday. Why do I always keep picking Friday? You've got to update your system by next week. And you're like, that's not on our roadmap. Why should we put off our work to help this other team? Like, we have to achieve our roadmap to achieve our goals. So politics there. Also, we have to typically, when we're changing an interface that involves many teams, we have to get lots of people in the same room at the same time on a remote meeting, and that slows things down incredibly. Technology is really interesting when you have an octopus pattern or a pattern with many dependencies, because if you can centralize lots of the complexity in the octopus, you can save each one of those teams having to implement lots of logic. And just think about the cost of that for each one of those teams. So an example was, the way we were going to do the octopus, it would send a message out to all the services and get a response back. Now, one idea was, we'll put a message on the queue of each service. But then we had people saying, well, we don't have a message queue. We don't want to have to spin up a message queue every time we create a new service. That's a big overhead. So we were able to think, well, we can invert that. So the octopus could just call an API on these services. And all of the retry logic, etc., can be centralized in the octopus. Massive time saver. This is also where technology standardization can help. If you're all using the same technology stack, it might be possible for the octopus context to create some kind of client library. But more importantly, I think, a bit of upfront design here. Now, I know people hate upfront design. Please don't shoot me. But a bit of upfront design can save so much time here. I know when you're iterating and you own everything, it's fine to just put stuff out there and keep iterating it. But when you're putting stuff out there and other people depend on it, you can't iterate it as quickly. So if you can do some design up front, create some prototypes, work with one team at first, find a stable interface that's unlikely to change, you can save a lot of politics in the future. So there are some other patterns. I think we're a bit tight on time, so I won't talk about these too much, but these are where one concept goes through different stages in its cycle. That's quite a typical pattern. And we have a pattern where we have a concept that goes through different stages in its life cycle, and each team owns a different step of that process. But at any point in the process, it can be kicked back to another team. And this is interesting because a few situations I've worked in, once it gets to a specific part of the stage, this team thinks they own it, but then it gets kicked back and there's challenges over who owns this in-progress piece of work now. So lots of interesting patterns there. Also patterns around how we integrate different teams in the organization, different specialities. So one pattern is called centralized partnership. And this is about trying to find a balance for user experience. So a lot of user experience people, they say, we like the idea of cross-functional teams embedding UX people in the team, but UX people need to work together on consistent user journeys. So a pattern they tried to establish in this book is trying to find a halfway house here. So lots of interesting patterns out there. And now I'd like to talk about some evolutionary patterns. And evolutionary patterns are where we go from one structure to another for either economical, political, or technical reasons. Now, the first pattern is called slice and scale. This is where we want to slice something, an existing sub-capability, and make it its own capability. The business wants the ability to invest in this new capability and scale it up without having to invest in all the other things it's coupled to. So again, an example of this is the music company I worked for. In the early days of the company, it was all about having an exclusive catalog. If you didn't have the music in your catalog, you couldn't compete with iTunes, game over. That was table stakes. But as the company matured and the industry matured, and they got all of these, like all of the popular music in their catalog, now it was different. Now the competitive advantage was making it easier for people to find the music they were looking for. So the company, the business, as it was growing from a startup, okay, now we need to invest in search and recommendations. So slice them out, assign each of those capabilities to a new team, and we can invest a full-time team working continuously on those new core capabilities. So what are some of the trade-offs with this pattern? Well, on the economic side, it's about understanding the market and how the market's changing, how customer expectations are changing, how they're going from wanting just being happy with having the music there to I want to find my music 10 times quicker than I used to with an advanced search. Politics, it can be interesting when you're saying, okay, this one team, you did a great job of managing these 3 sub-capabilities, but now we're taking it away from you. Like you feel a sense of ownership. You've worked on that search, you've made it great, and now people are taking it away from you. Obviously, it makes sense from a business point of view, but people have emotions. And obviously, when things are coupled technically, it's easy to draw boxes on a diagram like this where you pull one thing from here, but untangling those code bases could like weeks or months, or it might have to be a complete rewrite. So there's a lot of cost there that may be necessary. Now, one thing we can do as socio-technical architects is understand the industry we're working and anticipate future change. Simon Wardley's been working on his style of strategic mapping, and he shows how an industry will evolve. So as socio-technical architects, we can think about creating modular systems, preparing for how our code may evolve in the future. This also takes us on to another interesting topic, which is design we need cohesion at every level. Think about software. We have cohesive modules, into classes, into packages, exactly the same level at the architecture and the organization. Even though we've pulled out these 3 separate capabilities into distinct capabilities, there's still cohesion there, and those teams still need to work more closely than other teams in the organization. If you're familiar with the Spotify model, it's called a tribe. Now, I'm not talking about these patterns today, but trying to show I hadn't ignored it. So next pattern is slice and scatter. This is where we want to slice something up and scatter it among different modules in the system. So an example here is, I was modeling a system with one company not too long ago, and they had this rules context. Everything about rules was in it. I don't think it was a rules engine. I think they had like thousands of hard-coded rules. And they were like, oh, this rules thing is a bottleneck. Lots of other teams depend on it. I'm like, well, what if it doesn't have to be a bottleneck? Like, what if there were different kinds of rules? And we can take some rules and give them to this team. Take some of these rules and give them to this team. Take some of these rules, give them to this team. We've split the thing up, and now we have no dependencies. We have 3 autonomous contexts. So what are the trade-offs here? Well, firstly, it can be an expensive change. You've got changing the architecture, decoupling services, taking teams apart. It's not cheap. Breaking up a team, again, teams are working together. They've formed long-term relationships. They get used to working with each other. And now you're telling them, yeah, you're a great team. We're breaking you up. I never like it when I'm having to be taken out of a team to move to other teams. You lose that consistency, which you can enjoy. And again, it can be impossible to decompose some software systems. So next pattern is slice and merge. And this is kind of the opposite. This is where we have a couple of services or a couple of contexts, and they're tightly coupled. And there's lots of interdependence between those teams, friction and bottlenecks. And you're like, can we do something different here? And what you notice in a lot of domains, a lot of the way companies have architected their systems, it's a very small part of one service and a very small part of another service that are tightly coupled. And if you pull those things out, you can have 3 autonomous services instead of 2 tightly coupled ones, and obviously the teams have more autonomy. So what are some of the trade-offs here? So it's okay to highlight a very tight dependency, but before you make your case to the business you want to break it up, you need to be sure that these things really are changing a lot and you're wasting a lot of time on collaborative overheads. Secondly, now you've got 3 teams to coordinate, right? Make sure you're not taking it going from 2 teams to put a text box on a web page to 3 teams to put a text box on a web page, because that's not nice. And again, technical separation may be super painful. So those are the patterns. I hope you started to get a kind of a feel for the different kinds of patterns. But now I'd like to quickly talk about some of the principles and practices you can use. Practices you can use to design systems, and the principles you can look for even when you don't recognize any patterns. So the first principle is, the top-down principle is, when you're working in an organization, we don't really want to have lots of teams, because then we have to coordinate them. And we go from just working on adding value to coordinating teams. But that doesn't scale. In an organization, we have to have multiple teams. We have to make them work together. So our goal as architects is to understand which parts of the system give the most value to the business. Can we make those autonomous so we can continue to make changes in those parts of the system as quickly as possible? Now, there's a problem with that. It's top-down. When we're designing systems, we have to take also a bottom-up perspective. We can't naively model a system based on how we'd like to organize teams from a business point of view. And I've seen this happen a lot of times. The team structure gets defined by some managers in a meeting who are completely disconnected from the system. And there's all kinds of bottlenecks between those teams. So what we need to do is to actually model the domain we're working in. We need to understand which concepts we're modeling in our software systems. Which of those concepts are naturally tightly coupled? What are the contours in our domain? And we have to make sure that we're not splitting them up and creating bottlenecks. From promise theory's perspective, promise theory tells us if we want to create a system, not just a software system, but a system of autonomous agents, we need to have agents that can make unconditional promises. So I'm asking your team to implement a feature. You want to say to me, I can implement that feature, I can have it done, etc., without depending on any other teams. If you have to say, well, I can put a text box on a web page, but I need 5 other teams to make back-end changes, that's an unconditional promise, and you have less autonomy. Now, promise theory tells us that we have to understand those promises, and we have to model a system from the bottom up. We have to understand, here's the promise I'd like to make. What does that agent need to own? Which data, which policies, which rules? Which parts of the system does that agent need to own in order to tell you, I can unconditionally make you that promise? So how do we do that? Event storming. Event storming is how you model systems. Like, I learned event storming a few years ago, and it completely changed everything. If you're not familiar with event storming, it basically goes something like this. Get a bunch of people, random people, developers, testers, business analysts, domain experts, UX designers, a bunch of people from across your business who work in different teams, put them all in a room with lots of wall space, fill them up with donuts and coffee, and give them a big pad of Post-it notes and tell them to model the system. How can that possibly work? Let me explain. So in the past, we haven't had a way to model systems collaboratively. But if we want to model systems and understand all of the interconnected pieces, we need to get a bunch of diverse perspectives, the UX perspective, developer perspective, domain expert perspective, different teams perspective. We need all of those perspectives to model the entire system. But we haven't been able to do that before because we haven't had a modeling technique and a similar notation, like developers with UML. That doesn't really catch on. Trying to stand around a whiteboard with 20 people watching you, that doesn't really work either. Then along came event storming, and it's so simple. You just use different colored Post-its to model different colored concepts in your system, like events and commands. And very quickly, you can get almost anyone in your organization modeling their part of the system. It is super powerful. And once you start visualizing systems, then you start understanding what are the most important parts of the system. What are those areas that we want to affect the least because they deliver most business value? You also identify cohesion and promises. You're modeling the system at a level where you have these individual concepts in your domain, and you can see which ones are tightly related and are very cohesive. And obviously, once you've modeled the system, you can then start exploring different designs for your teams and services. So what are some of the kind of design principles? So when you're looking for those boundaries in your system, obviously we've got the top-down perspective. So top-down perspective is which parts of the system have the most business value. Let's put a boundary around those. Which parts of the system are most cohesive? Which things change together? Let's put a boundary around those. Again, thinking back to promise theory, let's strive for unconditional promises. Where can we put a boundary that would enable a team to be autonomous and make the changes we're going to ask them to make without having to depend on other teams? Climatic patterns. So look at your system. If we put boundaries here, that would be amazing for the work we've done for the past 6 months. We'd have super autonomous teams. But what's happening in the next 6 months and the next 12 months? Do these boundaries satisfy those goals? Are you thinking ahead to what is likely to change? And also, we get back to the politics, right? We have to be aware that where we place the boundaries affects people's motivation and affects power in the organization. It's okay to put some boundaries here, but think about the way companies work. Managers are trying to increase their headcounts so they can manage larger teams and get promoted. If you're taking headcount away or power away from some manager, you might have a hard time there. I've had that problem many times. So lots of other modeling techniques for modeling different aspects of systems. It's not just about event storming, but event storming is the most useful. And something I came across recently, which I think is going to be a game changer for the way we build systems, and especially how we architect them, is forensic analysis. So Adam Thornhill, he uses version control history, not just from one code base, but from all your code bases. And he can tell you which parts of the system are changing at the same time. Even services that aren't in the same code base, he can tell you which things change at the same time. And he can tell you which teams are tightly coupled. So I think there's a lot of opportunity for exploration here. One final thing there. So obviously, when we design systems, it's a continuous process. The market's constantly changing. Our software architecture is constantly changing. So the concepts I've talked about, they fit into this 5-step model. And this is based on Simon Wardley's strategy cycle. So I highly recommend you check out his strategy cycle, because it's basically strategy. It's a pattern for implementing strategy. And software architecture and organization design is strategy. So final part of the talk, just going to quickly wrap up now. I know we're very close to running out of time. So my point is this. Modern organizations now, we've got serverless, we've got the cloud. Developers are being freed up to spend more time elsewhere. We can't get an advantage through infrastructure anymore. You can buy best practice infrastructure off the shelf. It's about how we evolve systems, how quickly we evolve them, and how quickly we set up our organizations, or how effectively we model our teams to evolve those systems. So my challenge to you is start modeling systems. Learn about domain-driven design, learn about event storming, and start modeling systems. But remember, they're socio-technical systems, not just software systems. And start looking for your own patterns. Build your own playbook, and share your patterns. Let's try and make it obvious, the patterns we're seeing in different companies in different domains. I don't want to go back and keep working in companies where 5 project managers to put a text box on a web page. We can do better than this. By making these patterns clear and obvious and giving them a name, we can quickly say, activity-oriented architecture, we know the problems here, it doesn't fit with the kind of transformation we're trying to do. And so my closing remark is, I was recently in New York, and I found it super interesting. So New York is like a big, amazing technical city, like huge skyscrapers everywhere for miles. Times Square's like flashing lights, everything's going off. And yet, just 5 or 10 minutes away from Times Square, you're in a huge central park, and like all the noise dies down. You've got squirrels running around, people having fun. You don't even know you're in the city until you look up, and you can see those huge skyscrapers everywhere. It's like, it doesn't feel right. I'm like in a park, I can see giant skyscrapers. And then it finally made sense to me. Like New York understands the importance of both the technical and the social parts of designing systems. And that's why it's one of the most amazing cities. And I think we should all start thinking that way too. Anyway, I'm done now. Thank you. Okay, yeah, if anyone has any questions, like, please come and find me. I'm the guy with a walking stick. You can't miss me.